Hey guys, welcome back. So what we're looking at today is quadrilaterals beyond definition. So let's go ahead and jump right in. So what we're looking at here, we want to define congruence and similarity. So what do you know about two figures if they are congruent? Well, if two figures are congruent, then a series of transformations will make one land exactly on the other. So basically what that means is all the sides, all the angles, all of that has to be the exact same so that we could take and do rotations, reflections, translations to get from one image to the other so that when they're on top of each other, they are completely and utterly the same. So that is what congruence means. Now, similarity, what do you know about two figures if they are similar? Well, they are all the same shape, but different sizes. One is a dilation of the other. So this is when we use our dilations. Those are what's known as similar figures, not congruent, because they're not exactly the same. Their sides have a ratio between them because obviously we have that scale factor, and the angles have to stay the same. That's the one thing that has to stay the same. With our similar figures, the angles still have to be congruent to each other. They still have to be the same. But the sides, we've got that relationship between scale factor. So there's a ratio between them. All right, our next section, classifying quadrilaterals based on their properties. Using the information given, determine the most accurate classification of the quadrilateral. So it has 180-degree rotational symmetry. That would be a parallelogram. You could also say a rectangle. For number 6, has 90-degree rotational symmetry. That would be a square. That's the most exact classification there, because a square is both a rectangle and a rhombus would have 90-degree rotational symmetry as well, but a square is more exact. All right, number 11 has diagonals that are perpendicular. That would be a rhombus. It would also be a square. So you can include the others in here as well if you want. You don't have to go as specific as long as you list everything that is true for this. So we're just looking at these different properties of quadrilaterals. So you're only going to be using parallelogram, square, rhombus, or rectangle for these. No trapezoids will be used in this. Quadrilaterals is your key word for this lesson, quadrilaterals. All right, and last but not least, slope and distance. Find the slope between each pair of points, then using the Pythagorean theorem, find the distance between each pair of points. Distances should be provided in the most exact form. So slope, remember, is y2 minus y1 over x2 minus x1. So in this one, we have 0 minus negative 2 over 0 minus negative 3. So we have 2/3. Now, for the distance formula, 2 and 3 are the rise and run. They're the legs of a triangle that would give us the distance between these 2 points of the slope triangle. So we have 2 squared plus 3 squared equals c squared. 2 squared is 4. 3 squared is 9. So we have 13 equals c squared. Take the square root. So we have the square root of 13 equals c. We want to leave it as the square root of 13. We do not want to take and find the decimal of that. So for each of these, you're going to have two answers, one for slope, one for distance. All right, 15, we have 1 minus 13 over -5 minus -10. 1 minus 13 is -12 over -5 plus 10, because minus and negative, same thing's adding, is 5. So there's our slope. Then distance, we'll take a -12 squared plus 5 squared equals c squared. -12 squared is 144 plus 25 equals c squared. So we have 169 equals c squared. Take the square root. Now 169 is a perfect square. It gives us 13. So our distance is 13. So that's what you guys are doing for these. Now, if when you find the slope, you can reduce it down. So let's say this would have been -2 or -12 over 6, and our slope would just be -2. Use the original. Use this -12 and 5 for your distance. Otherwise, it's going to throw off the distance if you do it on a reduced scale. If you reduce it down, then it throws it all off. So make sure you use the original slope, not the reduced slope, okay? All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.